Alright, separable differential equations. They take the form of dy dx equals some function of x times another function of y. They're called differential equations because you've got a dy dx in the equation, and also they're separable because we can actually get all the y's on one side and all the x's on the other. So in this is the general form of separable differential equations. And if we divide both sides by g of y and multiply both sides by dx, so we bring the g of y over there, we leave the dy here over g of y, and we're going to multiply both sides by dx, so that will go, and we get f of x dx. Okay, so the dx has come over there and the gy's come down there. So that is a true equation, and if we find the integral of both sides, then the integral of 1 on g of y with respect to y is equal to the integral of f of x with respect to x. So let's just have a look at an example on how this would work. So we've got a differential equation dy dx equals y squared outside of 1 plus x. And we know there is an initial condition that when you put x equals 1 in the function, we get a value of y equal to 2. So this is going to help us find the value of c, the constant of integration. Okay, so this one we're trying to find this example here now. We've got g of y as y squared, and we've got f of x as 1 plus x. So we'll bring the y squared to the other side, so you've got dy over y squared, so dividing both sides by y squared. And then we're going to multiply both sides by dx, will be equal to 1 plus x dx. We can now integrate both sides, and 1 on y squared, don't forget, is equal to y to the minus 2. So when we integrate this with respect to y, we're going to integrate y to the minus 2. We add a power on the power, so we get y to the negative 1 all over negative 1. So we've integrated the left-hand side, is equal to the integral of the right-hand side will be equal to the integral of 1 is just equal to x plus x squared on 2 plus some constant of integration. That's the basic form. We don't want y to the minus 1. Our answer's got to have y equal. And we've also got a way of working out what c is, because we know when we put x equals 1 in here, we're going to get a value of 2. So first of all, though, it might be good to knock this into some sort of shape and get a value of what y might be. We can multiply both sides by negative 1, and we get y to the minus 1 equals minus x squared on 2 minus c. Now y to the minus 1 will be equal to 1 on y. So if I flip this side, I get y, and this at the moment is all over 1, so I can flip that side, and I'll get 1 over minus x squared on 2 minus c. Now we know when x equals 1, y is equal to 2 from the initial conditions that were given up here. When x is equal to 1, y is equal to 2. So we know that 2 is equal to 1 over minus 1 minus x is equal to 1. 1 squared is 1 over 2 minus c. We can make this a little bit better as 1 over minus 3 on 2, and that's equal to 2. 2, don't forget, is 2 over 1. So if we cross multiply, we multiply the 2 times the bottom. 2 times negative 3 on 2 is negative 3. 2 times negative c is negative 2c. and we cross multiply the other side. Okay, so we can take the negative 2c over here, and we get negative 3, take the negative 2c, would be equal to 2c, and we've got to bring that 1 over there, so it'll be minus 1. So negative 4, negative 3, negative 1 is negative 4, is equal to 2c, so c is equal to negative 2. So now we can substitute back in this equation here, because we want to find a function of y. So y is equal to 1 over negative x minus x squared on 2, now minus c. c is equal to negative 2, so it will be plus 2. And there is some school of thought to say that we should start an expression here with an expression in x with a positive, so we could bring that 2 out the front there. So we could say that's 1 over the positive 2 will allow us to start with a positive minus x squared on 2. So that's an example of a separable differential equation where we've got to find y. We know what dy dx is, but we've got to find y. And I call separable so that you can separate the x's from the y's, get all the y's on one side and all the x's on another. We then integrate both sides, and we make sure we get it all in terms of y equals. If we're given initial conditions, sometimes you're not, you just leave it with a c. But if you are given initial conditions, you then substitute back in to find out what the value of c becomes. And finally you put that value of c back in and come up with an expression or an equation for the function y.